Welcome, everybody, to my recurring Weather and Climate Office Hours series. I know there are now quite a few repeat visitors week on week, but there are, as always, a fair number of newcomers in each session. So if this is not your first time, welcome back. And if this is your first time viewing, welcome. I would like to remind folks that as of this month, the channel is now partially sponsored by Reask, a company that is rethinking Earth system risk in a warming climate. So today's topic, I wanted to split, as I often do, between some short-term weather in the Western U.S. and California, and then talk a little bit about the bigger picture, both in time and space, in terms of global conditions this summer. We look forward again into summer and fall. And I also wanted to touch on something that I raised in a recent short thread on social media, which is regarding why I have been kind of frustrated with some of the predictions and headlines surrounding fire season in California and the broader West this year, and why I think a lot of them are probably not correct. So I'll get into that as part of the seasonal conversation. There's one person who's mentioning the audio is low. Sometimes this is a user thing, but sometimes, for whatever reason, on my end, the audio does default to a very low microphone input. So I'm just going to check really quickly right now, and it does not look like the input is low on my end. So if you are experiencing low audio, you might want to check your computer settings. So in the short term, California and the West has been experiencing a prolonged heat wave, as was discussed in the last couple of sessions. If you're along the immediate coast, say in San Francisco or in Santa Monica or in a lot of other parts of the coast in between, you might be saying, what heat wave? This is a common refrain this time of year during heat waves that affect primarily inland areas. Because this is the time of year when the marine layer is particularly pronounced. Although this year it is even more pronounced than it normally would be at what is already peak season for May gray or now June gloom, the coastal stratus and fog along the California coast. Right now, the National Weather Service in Los Angeles, or Oxnard, just made an interesting quick statistical analysis yesterday where they found that, at least by some metrics, this is the cloudiest period in the late spring or early summer weeks since at least the 1970s at some of the airport observing sites. Now, granted, we don't have fully systematic records going back that far for cloudiness, because this is actually a surprisingly difficult variable to measure objectively. But at these automated airport weather reporting sites, this is something that suggests that certainly, whether or not it's truly the cloudiest late spring period, early summer period on record since the 70s, it clearly is one of the cloudier ones. Let's put it that way. A lot of other folks have mentioned this anecdotally, and that's an objective piece of information that definitely, I think, to at least a large degree, validates those anecdotes down in Southern California. Up in Northern California, folks have been mentioning how the onshore or even the coast parallel breezes have been really consistent and strong. That too is an anecdote borne out by the data. It has been unusually windy along the coast, and that is consistent with the fact that the nearshore ocean temperatures have cooled to near or below average temperatures along much of the immediate California coast in recent weeks. So not just the usual, the water's really chilly in May and June, which of course is always true in the upwelling zone off the northern and central California coast, but even a little bit cooler than that normally would be at this relatively chilly time of year. So that is keeping the coast quite cool most of the time, keeping a strong marine layer, keeping those breezes, leaving folks coastal denizens scratching their head a little bit as to where the heat is. Well, the answer is the heat is inland, and sometimes you don't have to go that far inland. In fact, there have been periods over the past couple of weeks where even just 10 or 20 miles from the coast, it's been over 100 degrees and quite hot. Not a great number of records broken. As far as I know, no monthly records or all-time records or anything like that. But quite a few daily records in some spots have been broken over the past week or so. Some places in the Great Basin have actually seen their hottest temperature this early in the season on record. So Las Vegas, for example, experiencing their hottest heat wave prior to June 15th on record during this current event. So that's a major population center that has been exceptionally hot during this period. Again, the same temperatures there in August would not be quite as anomalous, but given the time of year, they definitely have been. And parts of California that have been seeing the worst of this heat wave are actually not the population centers, but the far northern end of the Sacramento Valley and the mountains, the northern mountains and the foothills, where Red Bluff has hit a number of daily record high temperatures, been consistently well above 100 degrees up there. And also the overnight minimum temperatures have in a lot of ways been more remarkably warm, or I should say not cool, than daytime highs. So we haven't seen any 110, 115 degree record breaking daytime highs, but we sure have seen a lot of temperatures overnight not getting below the upper 60s or even the lower 70s Fahrenheit, especially in the thermal belts. And that's really warm, especially for a June heat wave. And that is really elevating the level of heat impacts, not only from human health perspective, because how cool at night really resets the clock on how much the body recovers from that heat. So if it doesn't get very low, if you don't have active air conditioning, you're sort of starting off at a disadvantage the following hot day. It also matters, of course, for both agricultural crops, those plants that are planted in fields, and also the natural environment. Ecosystems respond differently to heat waves that have very warm overnight temperatures. One thing that happens in unirrigated ecosystems, so in the vegetation that's out there where there's nobody directly applying water, is those really warm overnight temperatures can inhibit how much humidity recovery there is overnight. So if there's a wildfire burning, for example, that makes a big difference in the fire's ability to lie down, calm down, and for plants to not have that continual water stress 24 hours a day. So when it stays warm at night, that results in additional drying that continues throughout the night in a lot of ecosystems. And although we don't have any large multi-day or multi-week burning wildfires right now, so that's not particularly a problem at the moment, if that signature of really warm overnight temperatures during heat waves remains the rest of the season, as appears to be plausible, then that will play a bigger role down the road once we do have more significant fires burning across multiple days and weeks, keep them active into the overnight hours. And right now, it's helping to set the stage for that to occur because it's allowing for a longer window of vegetation drying throughout the overnight hours, not just during the peak daytime heating. So this has not been, a super extreme heat wave, but it's been a pretty prolonged one. And it's been a little bit of a subtle one in some ways, since a lot of the anomalous heat has actually come at night. Still has been warmer than average during the daytime, but not so extremely so. It's also been more pronounced across inland areas, most extreme across the Great Basin, somewhat less so across the mountains in northern Sacramento Valley, where there have been some records broken, and really not a very remarkable event at all along the California coast. Along the immediate beaches, perhaps not a heat event at all because of those cold, breezy, and damp nearshore conditions. And we had a bit of a break over the weekend. It got cooler again. Now it's getting hotter again. There are some new excessive heat warnings and heat advisories in effect in Northern California and the West as that heat resurges this week. So it's getting hotter again. Probably will peak at or below the levels we recently saw. So this doesn't necessarily look like a more extreme peak, but it does keep the heat wave going in inland areas for a particularly prolonged period of time, meaning that what this will probably happen now is that much of June will end up being much warmer than average across much of California and almost all of the Western U.S., when previously it looked like June might be the coolest month of the summer. That might still be true because the most extreme warmth is probably yet to come, But it is interesting that June has not been quite as cool as might have been the case. It has been along the immediate coast, and that's somewhat reassuring, but across inland areas, it has not been a particularly cool month so far, and it looks like that heat is going to continue. Right now, it appears likely that, as I mentioned, that there'll be some cooling and some breezy winds as that cooling occurs. So cooling is relative, of course, in the Central Valley. It'll likely still be in the 90s, not unusual temperature-wise this time of year, but following some higher heat in recent days, and given that the conditions are quite dry out there, those north breezes could result in quite high fire risk in the valley itself and in the foothills fringing the valley. And although this is not a super widespread major fire weather event, we have seen in recent years some pretty serious wildfires under conditions like this, mainly grass, some brush type fires. So in the lighter, flashier, faster responding fuel types that dry out more quickly in response to dry and or windy conditions. During these summertime wind events, they're not super extreme wind events. We're not seeing gusts of 70 to 100 miles an hour as we sometimes do in those autumn offshore wind events, but nonetheless, those 30 to 45 mile an hour gusts, if you get a fire going in the wrong place at the wrong time, can cause some significant problems. So fire risk is ramping up. There will be some periods of breezy to windy conditions that could get fires going. The risk right now is still mainly in grass and brush. The heavier vegetation, the forested areas in particular, are not yet particularly dry still, even with this heat. They're getting drier, but and some of them might be able to support a fire, but probably not at an extreme rate of spread or intensity yet, because it's still we still have the benefit of all that residual moisture from this winter and spring. That is increasingly less and less the case, though, in the grassland environment, and as we've seen with some recent grass fires that have spread quite quickly, we have a really high fuel loading in the grassy environments this year, with a lot of extra growth of grass and brush because of the last couple of years of wet and relatively mild conditions, now transitioning towards much hotter and drier conditions. A lot of that extra growth is now becoming potentially combustible fuel. So that's sort of what the outlook looks like right now. We're going to see this right now. We're back in sort of a warming wave, not an extreme heat wave, but a bit of a wave. And then let's see, cooling, relative cooling, with much breezier conditions and higher fire risk locally in the Sacramento Valley and the surrounding foothills as we round out the week. And then some relatively cooler conditions perhaps persisting into earlier next week before another significant heat wave surge by the end of June. So this will be at least 3 distinct waves of heat in June, of anomalous heat, and the third one is a little bit uncertain, but it could potentially be the most extreme of the 3, depending on how things go. There's a lot of uncertainty right now. I'll take a look at this a little more next week as we get closer to it, but what's interesting right now is that the model ensembles are suggesting that there could be a double-barreled heat wave across the U.S. So then this is somewhat unusual. Oftentimes, if you get a major ridge and a major heat dome over one half of North America or the U.S., on the other side, you often get a trough or it's unusually cool. But right now, there's some indication that both the West and the East may both have their own separate and possibly rather notable heat waves by the end of June, by June 20 to 25th or so. This remains to be seen, but essentially it would be as a result of 2 separate ridges, one anchored over the Four Corners and the other somewhere in the central eastern U.S., with a very weak trough in the center of the country where there would be pretty more typical temperatures, but somewhat unusual configuration where both the West and the East could both be hot or even record-breakingly hot as we get towards late June. Right now, the model ensembles are keying in on the eastern seaboard as having the worst of the 2 heat waves, in the sense that many daily records and perhaps some June monthly records could be at risk in the east, which is saying something because it can get quite hot there and humid as well. So this could be a fairly high impact heat wave later this month on the East Coast. But there's a few model members that really dampen that East Coast wave and instead have a much more extreme heat wave across the West. In fact, interestingly, the artificial intelligence or machine learning based European model, now granted not the ensemble, but the single deterministic run, shows quite an extreme Western heat wave, including virtually all of California at the expense of the Eastern U.S. heat wave. Some folks, by the way, have said, ooh, this is a great test of the European model. Either it's right or it's wrong, and we'll find out which one is which. Is the AI model better than the traditional one? The problem is you're comparing apples to oranges still in most cases. And right now, the AI-based European model, the experimental one that is available for public consumption, is only like a single member of the ECMWF ensemble. So the correct way to compare this would be, okay, are there any single members of the full traditional ECMWF deterministic model that is also producing an extreme heat wave across the West and not much across the East? And if so, it would be impossible to distinguish that one random member from the traditional ensemble from this single but AI-based run that's generating something similar. There are ways to test this, of course, and ideally the systematic validations will occur between the AI-based ensemble and the traditional ensemble, and so then you can have a more apples-to-apples comparison. That is, of course, what scientists are doing in the peer-reviewed literature, but some of the snapshots I've seen online are really trying to compare apples to oranges, so just wanted to highlight that as an aside. But suffice it to say that there is a pretty good chance that the heat will resurge across the Western U.S. and most of California, especially the interior of California, maybe not so much the coast, as we get into late June, following a cooler but breezier and higher fire risk period between now and then in many places. All right, so the next thing I want to do is I'm going to share my screen and look at the seasonal outlook, because the most recent international model ensemble, the one that I'm now using primarily because it is the broadest assortment of models from the greatest range of sources, including the widest range of information we can get, was just updated on June 10th. So this is not quite hot off the presses, but it's only 2 days old, so close enough given that we're talking about seasonal outlooks. So bear with me for a moment. Just going to share my screen here, as I often do, and you're going to see okay, here you go. Well, the first thing actually that you're going to see is the short term. So I might as well, I zoomed through this without showing, but I'll just bring it back up. Here's the European model ensemble, the traditional ensemble, by the way, not the AI-based one. Just temperature anomaly plot across the Western U.S. You see the current heat today centered primarily across the Great Basin, so Nevada and Utah, but also expanding across portions of interior California and Arizona and other adjacent states to a lesser extent. That fades by the beginning of next week, and we have near average or even cooler than average temps right along the immediate coast in California until we get to the following weekend and things really start to heat up once again, potentially across the entire Western U.S. But this is that double-barreled heat wave I was talking about, a broad region of heat in the Western U.S. and the Eastern U.S. with a region of just slightly less warm conditions in the middle, but not really pronounced cooling anywhere. Finally, maybe some relief over Mexico from that searing heat wave they've had in recent weeks, but perhaps just shifting some of it up to the north. And here is what it looks like if we consider the geopotential or the mid-level ridging anomalies. And these are kind of weak because we're at peak summer, so those are actually hard to interpret. So the normalized plots are a better way to go. And that shows a little bit that there might be some pretty strong subtropical ridging in that window with some uncertainty. So this is just sort of re-emphasizing what I was already talking about. What I really want to show now is some data from the seasonal prediction for what's coming over the next few months, both in the U.S. and really throughout North America. So on this website, by the way, there are global maps, but I'm focusing on North America because it's the closest zoom on California and the West that we can get from these data partners. All right, so I'm going to enlarge this slightly since I know it might be a little bit small on some people's screen. Okay, so what you're seeing, this is a geopotential height anomaly map prediction for June. And the main thing you can see is that because of global warming, it's red or orange everywhere. We don't really get below average geopotential heights anywhere anymore because in a warming climate, the half-mass layer of the atmosphere is almost always higher than it used to be almost all of the time because that warmer air is less dense and therefore the layer is thicker because the thickness of that layer is directly proportional to the temperature, the mean temperature in that layer of the atmosphere. So this is essentially saying how unusual is the height of the layer of the atmosphere where half of the mass of the air is above you and half of the mass of the air is below you. And what it's saying is, well, it's pretty much highly anomalous everywhere, but least so over Alaska and most so in a band stretching from about Hawaii to Hudson Bay, including parts of the southern U.S. This is for July, by the way, so this is for next month. And it's a little bit difficult to interpret because the absolute values are less important than the relative values. So the question is there anomalous ridginess versus troughiness? And so what we see is that there actually is a little bit of a relative trough across the Western U.S. in the July average, even though heights are above average everywhere. As we progress, though, this is now looking at August, that shifts, and then the pattern changes as we get into September in particular, where that's no longer the case, where there's no longer a mean trough along the west coast, but in fact this ridging shifts to be squarely over the desert southwest in California. So again, this is the outlook for September. And these are pretty large monthly scale anomaly plots, so suggesting there will actually be relative ridging over the southwest in the early autumn, and then even further intensifying in October with this huge persistent monthly scale ridge anchored over the west in autumn and continuing potentially into November. This is a bit concerning because what it suggests, as previously intimated, is that the summer may become progressively more anomalously hot as we go through the consecutive months. So least so in June, a little more so in August, but especially September, October, and November. This is also a pattern favorable for drier than average conditions, and so I want to go through that now. So that was the geopotential height anomaly. This is what happens if we look at, what are we trying to take a look at here? Here is, okay, yes, this is what I wanted to show next. I'll zoom in a little bit more. This is the 850 millibar temperature anomaly. So this is the how unusually warm or cool is the atmosphere a couple thousand feet above the ground. So it gives you a little bit smoother of a view than you get if you look at surface temperature because you're above the coastal mountains, you're above the marine layer. It gives you a better sense of what the air mass overall is doing. Here is July. The map looks like it's on fire because, again, just about everywhere is red or orange over land in continental North America, and that includes most of the Rocky Mountain West, most of the Great Basin, and Southern California. But watch what happens, along with much of the rest of the continent, but watch what happens as we go into August. This big red blob actually expands a bit more north and west over more of California and the Western U.S. We get into September, the Pacific Northwest might see some relief as the initial effects of La Nina arrive. The rainy season can arrive up there often as early as September. But in the desert southwest and southern and central California, we're really just locked in under these really warm 850 millibar temperatures under that persistent ridge. And this big red blob extends again all the way from the subtropical ocean, south and west of California, all the way to eastern Canada. Here's October. Again, you see the seasonal progression. It gets a little bit suppressed, but again, the southwest in California stays unusually warm in the lower levels of the atmosphere all the way through October, and that actually expands again, going back to November. So this big red blob centered on the southwestern U.S. and the subtropics to over northwestern Mexico, this is going to be a major player in climate really from about August through November at least. And this is one of the reasons why I'm becoming increasingly concerned about the second half of fire season this year in particular. I'll get into that in a moment. So again, these are what the maps look like from the perspective of lower atmospheric temperature anomalies, that you're above the marine layer, there's less influence by topography. Let's take a look what happens if we look at the, that's not what I'm looking for here. This is what I'm looking for. Here's the surface temperatures. Now keep in mind, this is the same map, but instead of the lower atmosphere, we're talking about the actual temperature at about chest or head level on the average human. So the temperatures that we're actually experiencing near the ground that are comparable to the daytime high and low temperatures you hear on the daily weather report. This map shows a little bit more complexity, and it's not uniformly red, although honestly it still is red just about everywhere. There's a couple of smaller blue patches, one of which is right along the coast of Baja California and South Central California coast, offshore at least. One thing to keep in mind is that this is still a coarse resolution climate model ensemble. It does not know exactly where the coastline is, so you kind of need to squint a bit at this map. Anything on scales less than about 100 miles wide, those variations aren't important. So essentially, the exact positioning of the coastline on the map outline is not where the coastline actually is in the coarse resolution climate model. The coastal mountains may not really exist at this level of coarse granularity. The Sierra Nevada also may not exist in the same way. It's mainly just seeing this gradual slope upward from the ocean to the Great Basin. So that's kind of why you see this gradient here from east to west. Don't take it too literally, but taken somewhat figuratively, what I'm seeing is that for July, there's a very strong signal for very hot, very anomalously hot, maybe record-breakingly hot conditions in the central U.S. and the interior parts of the Western U.S. This includes most of the Rocky Mountains, much of the Great Basin, and also parts of the interior, again, of California. Along the coast, there's much less of a heat signal, especially because there is actually an indication of some of near to slightly below average temperatures along the immediate coast. I'll get into why that might be the case in a moment. Going forward into August, we see that extreme surface temperature anomaly expands farther westward. Now we're getting all the way into the fully into the Great Basin, and even closer to the California coast as we get into August. This is a huge region of well above average temperatures over most of North America. Really all of North America, some just more extreme than others, except for maybe parts of Alaska, as we get into August. September, something a little bit interesting happens, is this relative cool patch with the cool upwelling along the immediate coast in the ensemble average is a little bit more widespread. These extremely hot temperatures, anomalously hot temperatures across inland parts of the West continue as we get into autumn, persist into October, actually get even closer to the coast with an even stronger contrast between slightly cool offshore temperatures and very hot inland temperatures. And then in November, this warm blob even takes over to an even greater extent, and we lose that cool coastal influence. So overall, what I think this is telling us is the difference between the 850 millibar lower atmospheric temperatures and the surface temperatures is telling us that along the immediate coast, there is going to be a strongly modulating influence of slightly cooler than average nearshore temperatures. And one way to confirm that that's actually what's happening is we can look at the same map again, but this is for the wind signal. So are the winds likely to be above or below average over the same period? And when we look at this, indeed, we see that in July, the subtropical high pressure system off the coast of California will drive a pretty high likelihood of stronger than average oceanic winds in this region. That was July. This is August, same story. September, that fades a little bit, and by October, that influence is gone, and we actually start to see the opposite effect as we get into November. So really saying that breezy, foggy, and cool conditions along the immediate coast might be amplified this summer. And so a really strong contrast between near to below average temperatures along the immediate coast much of the time, at least through August, unusually cool, windy, and foggy, with extremely hot temperatures across inland areas, including the potential for record-breaking heat. So again, yet another summer with a really strong contrast, even stronger than usual, given that it's already quite strong, inland areas versus the coast in California. But this effect will likely go away starting around September, and that is when coastal California might start to see some really significant heat waves given how hot the overlying air mass. This is where that 850 millibar temperature anomaly in September and October and November comes in. That's much more likely to make it to the coast that time of year when the coastal influence goes away, and in fact that's indeed indicated by the fact that the nearshore breezes may be even lighter than usual that time of year this year. The last thing I wanted to take a look at was, although most of California doesn't see a lot of summertime precipitation, there's a bit more in the southeastern deserts that are more exposed to the monsoon, and across the Sierra Nevada also get occasional afternoon thunderstorms. This is a really stark map showing that there's a very high likelihood of a very weak monsoon this year across the entire western United States. The signal has actually gotten stronger and stronger with each passing month. This is July now. July is often the first of the two peak months of the monsoon. Very strong dry signal, bleeding over a bit into California in the parts of the state that see some monsoonal precipitation, and even becoming a little bit stronger and shifting westward in August, the other peak monsoon month. Very strong dry signal for essentially the entire monsoon region in Mexico and the United States this summer. This is not good news from a drought re-intensification or wildfire perspective. Then, as we get into September, this is really not the monsoon season anymore, but this is potentially heat wave and offshore wind season, although some Septembers we've seen early season rain events in California that have short-circuited fire season. We've seen this a couple times in recent years. We were sort of saved by the bell, either with an early season Pacific storm or a late season tropical remnant system. Think Tropical Storm Hillary last August, or some early September precipitation from the Pacific, the cooler temperate Pacific the year before that. There is a low likelihood of that happening this year, lower than average in fact, because there's a pretty strong dry signal across the Western U.S. into September. And in fact, this becomes more meaningful a little bit in California in September because it means that there's a pretty low chance that we're going to be saved by the bell in that way again this year. That's particularly true because that dry signal then persists into October across California and the Western U.S. So there's a higher than average likelihood that at least September and October will be drier and hotter than average in California. That is going to be the peak of fire season, and I think that there's a much lower likelihood than recent years that we're going to see a precipitation event that time of year that mitigates in an unexpected way. Is it impossible? It's never impossible. But there's a strong tilt in the odds right now towards the September and October that are significantly hotter than average and that do not experience that does not experience an early onset of the rainy season or any sort of weird saved by the bell type rain events that short circuit fire season. There's even a weak drier than average signal into November, although that's mainly across the desert southwest and northern Mexico, so a weaker signal going into November. But of course, the real concern about fire season, I think, is likely to be September and October, perhaps August as well in some spots. But it may last longer into the fall across most of the Western U.S., maybe not in the Pacific Northwest. I don't think this will necessarily be a late fire season in the Pacific Northwest. But everywhere else, the interior West, California, the Rockies, the Southwest, this is likely to be a fire season that starts, maybe near average, maybe even more slowly than average in some spots, but rapidly accelerates sometime around later in July or August, and peaks intensely and potentially fairly late into September and October, even in places away from coastal California where the peak of fire season is historically earlier. So coastal California often has those warm offshore winds in September and October that fairly frequently drive a kind of a late shift in fire season relative to the hottest months of the year. This year, I think that September and October could be very active across almost all of the western United States except for the Pacific Northwest. So maybe not Washington, maybe not Oregon, but almost certainly so in California, Arizona, New Mexico, Nevada, Utah, Colorado, and maybe the Northern Rockies as well. The other piece of this, putting together, and this is coming back to the fire season component, and I'll bring my, I'm going to pause actually for a moment, bring my camera back so you can see my face. I can see what questions have come in. In the meantime, I'm going to justify my fire season claims a little bit more in a moment, but just want to see what's come in. Mainly some comments. Okay. Essentially, what's been a little bit frustrating is to see newspaper headlines or even official forecasts, some by predictive services and various entities in the federal government, by private entities and others, who have said that this year is likely to be a below to near average fire season across the West generally and specifically in California. Now, I'm going to start with a huge caveat that locally your mileage will vary. There are many different ecosystems in the West, and it's quite possible to have fire seasons that look very different in different ecosystems. In fact, I actually think that's likely to be the case this year, with perhaps the high altitude forests seeing the least dramatic fire season, and the low elevation grasslands and scrubland and chaparral type environments seeing the most active conditions. But even within that, there are some generalities I think that we can make. One is that we've seen a lot of growth of additional fine fuels. If you're not in the fire services, fine fuels essentially means vegetation that has low diameter. So think of the diameter of a twig or a blade of grass versus a tree trunk. Obviously, a blade of grass is going to have the lowest diameter compared to a mature tree trunk on the ground or something, a log on the ground. Those grasses are going to respond the fastest to changes in environmental conditions. So you often call grasses anywhere from like 1 to perhaps 10-hour fuels, meaning that over the course of a single day, over the course of just 1 to 10 hours, some people have work days that are longer than that, that grass can respond rapidly to changes in temperature and humidity. So if it starts off kind of damp in the morning, but it becomes extremely hot, dry, and windy by afternoon, you can conceivably have a fine fuel driven fire, so a grass fire, just 10 to 12 hours after that grass was fairly damp, if you have conditions that are favorable for rapid drying. On the other end of the spectrum, you have 1,000-hour or even 10,000-hour fuels, which are essentially giant logs on the forest floor, so non-living trees, logs, with diameters that can be in the multiple feet. So a blade of grass, think a tiny fraction of an inch in diameter, but a log on the forest floor could be many feet in diameter if we're talking a particularly large tree. And the hours sort of responds to the intrinsic response time. What is sort of the period over which this type of potential wildfire fuel is integrating signals and information from the environment that contribute to its dryness level, or essentially its flammability. So grasses respond quickly, they dry out quickly, and they moisten up quickly. 1,000 or 10,000 hour fuels, these big logs on the forest floor, they don't respond quickly. If a big log is damp on the forest floor in the morning and it's extremely hot, dry, and windy all afternoon, it's still going to be damp that evening. In fact, you get a week of hot, dry, windy weather, and that log is likely still to be pretty damp. But if you get a month or two of exceptionally hot, dry weather, then that's a different story, because we're talking about fuels that do start to respond to continuously dry, hot, windy conditions over a couple of weeks to a couple of months types period. So what we're seeing right now is that the fine fuels are drying out across the West, the grasses, and increasingly as we see these persistent heat waves, maybe the sort of the intermediate fuels as well. So thinking about like the 10 to 100 hour fuels, thinking about that dead brush essentially. So grass and dead brush, that kind of material, that kind of vegetation is starting to become pretty dry in many areas. Again, your mileage may vary locally. Whether you're on a north-facing slope versus a south-facing slope, that matters. The south-facing stuff dries out sooner because there's more sunlight, because it's hotter. But generally speaking, we're seeing that the grasses have cured. We're seeing big grass fires now. We're seeing some brush fires, not seeing much forest fire activity. This is sort of the usual progression in a typical year. You start to see grass fires, that happens first, then you start to see brush fires, and then you see more significant forest fire activity. You don't always see that third thing, by the way. Sometimes it never dries out enough. But some years, you start early and you start seeing activity in all three of these classes. This year, we're seeing a pretty traditional progression, and it's starting in grass, moving into brush, and we're not really seeing enough drying for the big forest fires yet. But the challenge is that this year, after a couple of wet years across a lot of the West, we have had a lot of extra growth of grass and brush. So there is more fuel for the fire. It's a figure of speech, but in this case, it's quite literal. There is literally more biomass, more carbon available in these grassland and brushy ecosystems, or in settings where there is a mix of grass, brush, and trees. There is more fine fuel available than there would be. So the only mitigating factor during severe droughts, for example, is you don't get as much growth of grass and brush. So what's available is super dry and super flammable. Excuse me. But there is less of it in the first place. Now, this year, we've got a lot of additional biomass available in these settings. It's not yet reached extreme levels, peak season levels of dryness, although it is now reaching levels that are dry enough to burn. We've seen that recently. But the challenge is that now we've got a bunch of extra fuel loading. We've got extra grass. In places where that's the primary vegetation type, we're going to start to see larger and more significant fires under windy, dry conditions moving forward. This includes some of the coast ranges in the Bay Area and Southern California. This also includes parts of the Great Basin and the desert regions where there isn't always as much grass and brush, but in the wet years we see a lot of extra growth. We see more contiguous fuels, as I've talked about before. But that's what's happening right now. We're starting to see activity there. When it's really windy, you could potentially get more significant fires that threaten communities, because grass fires can still threaten communities, even though they usually have a much lower energetic profile than high-intensity brush or forest fires because of the amount of biomass that's actually available to the flaming front, as it's called. But right now, what we've got is a situation where the grasses are drying out. We have an expectation of a particularly hot and dry summer across virtually the entire West, away from the immediate Pacific coastline. So I'm accepting the 10 or 20 miles along the actual ocean, but everyone other than that sort of falls into this category, all the way to the Ogallala Aquifer on the east of the Rockies, essentially. This is a huge region we're talking about. Hot, unusually hot, and unusually dry, even relative to recent heat and dryness in recent summers. That's saying a lot. So, but now we have this 1-2 punch, essentially. We have lots of extra growth from these last couple of years that have been relatively mild and wet. We've also had less fire activity the last couple of years, so we haven't had as much area burned. There are fewer recent burn areas. There's been less natural reduction in the biomass in some areas. Now, in places where we've recently had prescribed fire, right now, by the way, we still have pretty favorable conditions for widespread prescribed fire in a lot of the West before things reach peak seasonal dryness. Risk has been mitigated in some of those places that have been engaged in more active prescribed and other purposeful burning to reduce risk. But everywhere else, this lack of fires over the last couple of years actually means that the risk is a bit higher than it would be otherwise, because all of that fuel that accumulated over the past couple of years, it didn't burn over the past couple of years. So we have all this extra grass and brush growth. A lot of it didn't burn in recent years, so now we have a more distant fire history in many places. Virtually everywhere hasn't burned at least in 2 or 3 years now, and some places that saw activity in the 2010s now, we're getting close to 5 or 10 years since those areas burned, so a lot of that has filled in with the grass and brush in recent years. Now, though, we also have a summer that's expected to be exceptionally hot and dry in inland areas, so not only are we going to dry out that grass and brush that's overly abundant right now, but we're going to start to dry out those 100 and 1,000-hour fuels later this summer too. So we're certainly starting out with primarily grass and brush fires, and that's probably going to continue for a while. But come August and September, and remember, those might be the most anomalously hot months and dry months in some parts of the West of the entire year, we're going to see really aggressive drying of those 1,000-hour fuels as well. Now, of course, by that point, the grass and brush will be really crispy, tinder dry. So by that point, I think all of the fuel models will be pretty toasty, so to speak. And there may be a couple of exceptions, really high elevations where there's been really good snowpack the last couple of years. That might be accepted. So we might still not see a lot of big fires in the Rockies over 8,000 or 10,000 feet. We didn't used to historically, although we have in recent years because of the exceptional drought and heat waves. That might be one area plus the immediate coast that's sort of exempted from this conversation, but just about everywhere else, if you're not within about 10 or 15 miles of the coast of the Pacific Ocean and you're not living well above 8,000 feet, this prediction of a rapidly accelerating fire season likely applies to you. If you live near grasslands or brushy areas, it applies starting essentially now, but especially by the time we get to July. If you live in the forests, you probably have another month or so, but this is mainly a concern from August through October. And this includes not only the usual autumn risk zones along the coast of California, but also the interior west outside of the Pacific Northwest. And what's frustrating to me is that, a lot of these predictions and these headlines are based on, quite frankly, unsophisticated predictive approaches, looking at historical analogs. Does this year look similar to previous years? I mean, there can be some value in this, but the problem is we live in a very non-stationary climate. Every year, essentially, that we experience today is significantly warmer than almost every year we experienced 50 or 60 years ago in California and the West. I mean, that's just a very different situation. And also, we're experiencing very unusual combinations of record warming and El Nino to La Nina transitions and things like this in ways that I just don't think lend themselves to using analogs as a consistent way to predict what's going to happen next, especially, and this is the part that I think is particularly frustrating, especially given that we do have reasonably good seasonal predictive models that don't rely on analogs, but are actually looking at the initial conditions and using physics and other basic principles of science to predict forward in time, much like we make weather predictions, to say, here's what the tilt and the odds will look like. And right now, those dynamical predictions for the rest of the season are giving us a remarkably consistent and strong signal for a very hot and very dry summer across the interior west. Again, the signal's a little more mixed along the coast, the immediate coast, but everywhere else this is an overwhelmingly strong signal, and a lot of these fire season predictions take this into account very little, if at all, even though it's one of the most important tools we have at our disposal. And also thinking both farther back in time as well as forward in time is another piece that I think sometimes is lacking in these predictions, which is to say, part of what's going on right now is that it is the legacy of what's happened the last couple of years. That overabundance of grass and brush, it isn't just a function of the fact this past winter was relatively wet and mild in places like California, but it's also the fact, the product of the fact that the previous winter was also exceptionally wet, a colder one with a lot of snowpack in the mountains, but 2 consecutive wet years across much of California, the Great Basin, and the desert Southwest. A lot of places where there are very extensive regions of at least potential grass and brush. And so ignoring that history, I think, is a frustrating piece of this as well. So if you put these 2 pieces together, the fact it's been really wet and relatively mild in comparative terms over the past couple of years, lots of extra growth and low fire activity, with the fact that we have a really strong seasonal prediction this year. We don't always. Some years there isn't much we can say about seasonal scale predictability. This particular summer and fall, there appears to be a very strong signal towards hot and dry across a very broad region. So I'm fairly comfortable saying that the overall progression, I would say, this fire season is likely to be from near to below average start. That sounds reasonable, I get that. But that early season behavior is not going to be at all predictive of what happens in the second half of the season, to a greater extent than is usually the case. You might say, well, of course, always you have milder fire conditions in May and June than you do in August and September. And of course, that is the usual seasonal progression. But what I'm arguing is that the contrast between the mildness of the early season and the severity of the late season will be even greater than it would normally be. There are wild cards, of course. Many wildfires in the West. In some places like coastal California, even a majority of wildfires are ignited by human activities. That does not mean there are arsonists running around everywhere. Nearly the vast majority of human-ignited fires are not intentionally ignited fires. They're accidental. This includes things even like power line ignitions, which have declined a bit in recent years in California at least. But other things like you're unlucky enough to have your house catch on fire during a Santa Ana windstorm, and of course that's going to blow the embers into the brush around your house. That starts a wildfire. That's usually not anybody's fault. It's just a particularly bad piece of luck. Your car breaks down, and you pull over to the side of the road, and you're a little too close to the dry brush with that hot undercarriage of the car, or you get a flat tire and you can't pull over fast enough and there's some sparks from the rim. Well, that's another way to start a fire. California, at one point, the largest fire in state history was ignited by a person hammering a stake into the ground on a relatively dry, breezy day. So, sure, there are ways you can mitigate some of those risks, but the point is there's an almost infinite number of sparks out there on the landscape. There's going to be human ignitions no matter what. We can't really predict, though, whether they're going to occur under the worst possible conditions, extreme heat wave, Santa Ana wind outbreak, or under relatively ho-hum, more mild conditions in between heat waves. This is where people being careful can really be beneficial, because not all ignitions are equal. You can get a grass fire on a relatively calm, mild day. It might burn 100 acres, not necessarily a huge deal, plenty of resources to deal with it. You start the same fire on an extreme offshore wind day, and it's a completely different story. And so this is why there's often advice to not mow your lawn or do yard work with power tools or anything that generates sparks. Certainly when it's hot, dry, and windy in general, but even the advice to do it early in the morning or late at night, when the temperatures are lower and the humidity is higher. So we can't predict those human ignitions. It's largely stochastic. We generally know that there's more in places where people live, which makes sense. But beyond that, we don't know if they're going to occur under the better versus worse conditions. The other part we can't really predict, and this is more meteorological, we don't know how many or how strong the offshore wind events this fall will be. Maybe we'll get really lucky and this will be a hot but kind of still autumn. That would probably be the plausible best case scenario, given that it looks like it's going to be quite hot and quite dry. We can't really predict the occurrence of autumn offshore wind events, so maybe we'll get lucky. They won't be particularly strong, frequent, or widespread. That's just a keep my fingers crossed type thing. That's not really a prediction because we don't really have the ability to predict. Same thing with dry lightning events. We don't really have the ability to predict whether or not there will be substantive dry lightning outbreaks, although what I will say is that any lightning at all becomes more and more of a problem the drier the ambient conditions become, and we do expect it to be a particularly hot, dry summer, so I do think that there's an increased likelihood of lightning ignitions across the interior west this summer, including parts of California, not necessarily because I expect there to be more lightning, but because it's quite likely that the conditional fire given a lightning strike, that conditional likelihood goes way up in a year like this one. So there probably will be some increased risk of lightning fires, even though I can't say a lot about the actual likelihood of lightning versus other years this year. So we can't really predict the frequency of dry lightning events. We can't really predict the frequency of autumn offshore wind events at this point. Those are the unpredictable elements of fire season. We also can't predict human behavior, ignitions either. I can tell you that there's almost certainly likely to be a lot of new ignitions on the 4th of July, into the early morning hours on the 5th of July, and you might be able to guess why that is. It's because thousands and thousands of people across the Western U.S. set off fireworks, most of which are illegal where they're set off, and a lot of them end up igniting grass and brush fires. Again, keep our fingers crossed there's no windy conditions on the 4th of July week this year. But the point is, there are predictable elements to fire season, and there are unpredictable elements when it comes to fire season. And the predictable elements, everything that I can see is pushing us in a direction towards much higher risk in the second half of the season as we transition towards hotter and drier conditions. So I do think that the second half of the season will be a lot more active than the first half, and that it may last longer into the autumn than usual. So it may have a longer, more intense peak later in the season across a broader area than would usually be the case. Even if the statistics come July, the end of July, are near to below average. So I'm telling you right now, and I know there'll be headlines because there are every year, that this is a quiet fire season because at the end of July nothing bad has happened. It'd be great if nothing bad has happened by the end of July, but what I'm saying is don't let your guard down, because there's every reason to believe that there's going to be a big difference between the first and the second half. And I don't think this has been reflected in recent discussions about fire season, at least from certain media outlets and predictive services, especially some private ones. So I'm just trying to emphasize that this is going to be kind of an unusual year. This is very likely to be quite different from any of the past 4 or 5 years. 2020, of course, was just a terrible fire season through and through. Just a terrible fire season in California. There was no mitigating factor that I can think of at all. But 2021 through 2023 were quite different. They were a lot milder, and they started slow, and they stayed slow. This year might start relatively slow, but I do not think it's going to stay that way for much longer. We may have a few more weeks before things really take off, but we're already seeing some of the initial signs. And I think that the peak will be greatest late in the season. So we're almost up on the hour, so I do want to take some questions. I'm going to take a moment to sip some water. I'm going to look through the questions and see what we've got. Okay. Lots of folks commenting that it's quite hot today. No surprises there, unfortunately. Some comments, Peter comments that along the central coast, the excessive rain has made the grasses dense and tall. Counties are underfunded for roadside maintenance. This is unfortunately pretty common. I mean, the challenge is, of course, that grass and brush, it grows every year. These are either, well, they're either perennial plants or annual plants that just that reseed and regrow every year, depending on what we're talking about. And the challenge is this is a problem that doesn't go away. You can't, you get the funding, you get the crews to go and do brush clearing along a roadside this spring, and by next spring or the spring after, you kind of need to do it again because it's already grown back. So it can't just be this one and done or even once in a decade recurring cycle. You kind of have to do it every year, everywhere, and that's a major task, and there hasn't been enough resources. This is an argument for alternatives, solutions, and, it's difficult if you're going to clear it manually, or with a mower or something along roadsides. You got to have humans and physical trucks and equipment and cutting machines to do this everywhere. This is yet another argument for expanding the footprint of prescribed burning, because you can cover more ground, so to speak, and you can do it in areas that are really difficult to reach, where you might have to hike in otherwise, where cutting machines can't go. You can't do prescribed fires everywhere all the time. That is the practical reality, but I still think that there's a lot more space to be doing that kind of intervention at a much larger scale than we currently are. There is a movement towards it, but man, has it been painful and relatively slow relative to what it could be and what it probably would need to be to substantially mitigate the fuel loading problems. So it's trickier to do in neighborhoods, although not impossible. And this is, I know some folks are surprised to hear this, but it is possible. We have some colleagues and some friends who have actually hired private companies to do prescribed burns on land that they own in Northern California, precisely for this reason, because honestly, it's probably the most realistic and ecologically sound way to reduce fuel loading and reduce risk to individual structures in these environments. So anyway, that's yet another pitch for prescribed fire. But this is an issue where you can see along a lot of the roadsides, and this is of course not just true in California, but really all of the western states where there's been all this abundant grass and brush growth this year and last year. It's at waist to head height in a lot of spots along the immediate road fronts, and when there's a spark on a hot, dry, windy day, that's going to be an ignition point for a potentially significant wildfire. That is still how most wildfires ignite in the West. Realistically, the primary, if not the singular, natural cause of wildfires in the West is lightning, and I do think there will be an increased number of lightning ignitions this year, as I mentioned, but most of the other ones are human caused, and most of them are accidental, but a lot of those accidental starts are still preventable. Not all of them, but a lot of them. So, as usual, it may sound like a contradiction in terms to say, well, try not to start a wildfire yourself while saying we need to be doing more prescribed burning, But it really isn't, because the whole point of prescribed burning is you don't just do it willy-nilly across the landscape without planning and preparation. You accidentally spark a wildfire, you might well do it at the worst, in the worst possible time, when fire crews are occupied with other things, when it's hot, dry, and windy, when there's a heat wave coming. The whole point of prescribed burn is that you actually look ahead and you make sure you have the crews available and they're already on site, and you have a sense of what the weather's going to do. And if it's extremely hot, dry, and windy, you don't do the prescribed burn on that day. So I've had folks ask me about why a person might logically advocate both for more prescribed burning, but also trying to minimize the number of accidental wildfire ignitions, and that is precisely why. It matters where and when you do it. Casting sparks randomly across the landscape is not the safest or ideal way to achieve this. You really want to put thought into it, of course. But if you do put the thought into it, then you can achieve the benefits without most of the risk that you would get otherwise. Lots of similar reinforcing comments in the comment section today. There's a question: can broken glass start a fire? Lithium-ion batteries and lost drones. I mean, I'm not a combustion expert, but I know for a fact the answer is yes to both, because I've either seen or interacted with battalion chiefs and folks who've responded to these types of events to say that yes, it's unusual that broken glass would start a fire. It's a little more likely if it's like a full bottle, actually. So an empty bottle. You can imagine if anybody has ever tried to light a campfire or something with a magnifying glass. That's an extreme example where it's done purposefully and hopefully for a constructive purpose, but you can actually concentrate enough of the sun's energy into a small area to cause smoldering combustion initially, and then if it's hot and dry enough and there's enough oxygen, it can become open flame and start an actual fire. So that can happen with random garbage glass strewn about. It's even happened before, apparently, a couple of times in people's houses, where you put the wrong type of glass at the wrong angle relative to the incident sunlight, and it's like right adjacent to something super flammable, like a paper curtain or a stack of newspapers or something, and this started house fires that way. So it's a little bit of an outlier case, but it has happened often enough that, sometimes it's worth being cautious with things that can act as prisms for sunlight. When it comes to lithium-ion batteries, that's a well-known fire hazard in general. Cause of structure fires. There's no reason why it couldn't cause wildland fires. There have been a few cases where lithium batteries in vehicles, whether they're cars or smaller vehicles like golf carts or ATVs, or as is mentioned here, like drones, like personal flying drones. Those batteries are potentially flammable, and they can either be flammable or they can get hot enough that if they land in very dry brush or something, it can actually cause the vegetation. It can reach the combustion temperature. So, obviously, it's worth being careful. I don't think anybody wants to be the source of a fire, even if hopefully it wouldn't become a disaster. You never really know, and you certainly don't want. So it makes sense to be extra careful on days when the risk is high, because that's the much higher likelihood of things really going south. All right. And several folks have mentioned also that there is actually a crisis of wildland firefighter personnel. This has been sort of developing over years, and I work with a lot of folks who either are or have been in the past wildland firefighters themselves, either on the federal side, mostly Forest Service, or on the state of California side, so CAL FIRE or some of the regional agencies. And this is a real problem. Wildland firefighters don't get paid nearly as much as firefighters in urban settings. Municipal and city fire departments are structured and function very differently than wildland firefighting entities. In fact, most Forest Service firefighters are seasonal employees. They don't even have a year-round contract. The pay is low, irregular, and you don't even have the job for the whole year. So usually you've got to go do something else in the off-season. And it's honestly become quite difficult to recruit for reasons that are probably not too surprising. The pay is low, it's hard and dangerous work, and to add insult to injury, it's actually been getting difficult to get things like workers' compensation for the relatively high rate of injuries and illness that occur for folks in that profession. So, there's been gaps. There's a lot of unfilled positions in the Forest Service wildland side right now. I don't know if Cal Fire is the same, but there may be some similar issues, even though some of the underlying challenges are a bit different. Cal Fire is kind of unusual, by the way, in the sense that most states don't have dedicated wildland firefighting agencies. Obviously, Cal Fire does have some other responsibilities, but the main reason it exists, aside from some coverage gaps in more rural parts of the state with firefighting generally, and emergency response generally, is it is primarily an agency tasked with wildland firefighting, and it's very good at it. There are very few equivalents internationally. In fact, I'm not really sure there is a pure entity anywhere else. There are some places. There is, of course, there's the Forest Service in the U.S., but that's more distributed. The Forest Service is not primarily a fire. Some folks might argue otherwise, but it's not primarily a fire suppression agency. You have entities in Australia that function similarly to Cal Fire, although many of them are volunteer-based. So the Rural Fire Service in Australia. Increasingly, in some other countries, you're seeing plans drawn up for the need for these sorts of wildland firefighting agencies, as we see the growing number of wildland and urban interface fire disasters in recent years. But the reality is a lot of places that have these have either minimal or no dedicated large-scale wildland response abilities. It's usually somewhat ad hoc. There's limited equipment, limited personnel. And so in that sense, California is ahead of the game because of Cal Fire. But of course, the risks are a lot higher in California, and so there's a considerable task at hand there too. So, interesting global and regional perspective. It was interesting, here in Colorado when the Marshall Fire occurred a couple of years back. The initial response was hampered partly because, of course, it was so windy. So there wouldn't have been, even if it was California and Cal Fire, you wouldn't have seen any aircraft involved because of the violent windstorm anyway. It would have been a suicidal mission, essentially, to put aircraft up in that environment. And we've seen this on any number of large California fires under extremely windy conditions, that sometimes you can get observing aircraft to orbit at pretty high altitudes, but you really can't get retardant or water dropping aircraft. It's just not safe to fly that within the boundary layer that close to the surface under those conditions. But what you did also see is that it took a really long time for wildland firefighting resources to arrive, because there isn't, in the same way, a large statewide agency dedicated specifically for that purpose. It's sort of there's this call-in, there's this mutual aid request from departments all around, and eventually, that equipment got there. But there just isn't as much of it. There aren't as many aircraft, there aren't as many wildland firefighting vehicles, or firefighters who specialize specifically in wildland fire. The Forest Service crews, of course, this occurred in December, were mostly laid off for the season, because, again, it's a seasonal job for the most part. So interesting challenges arising as we start to see fire seasons persist later into the fall and even into the winter, as we've seen in some recent years with pretty consequential outcomes. All right, we're past the hour now, so you're getting some bonus minutes, but I'm just taking a look at any remaining comments. Yeah, David mentions that 2021 was also a significant fire year in the sense that the Caldor and the Dixie fires were also big events. That is true. So I guess I was referring more to 2023 and 2022 than 2021. Although even then, 2020 was just terrible because it affected essentially everybody. It felt like the whole state was on fire for much of August and September, following that huge lightning event earlier in the summer and that really major offshore wind event cycle in September. So, along with the record-shattering heat wave around Labor Day. So, everyone in California was suffering through pretty extreme smoke-related impacts. Tens of thousands of people were evacuated at any given time that year, and many thousands of structures burned. The Dixie Fire and the Caldor fires were, of course, very consequential events for the western slope and the crest of two very different parts of the Sierra. Although fire activity elsewhere in the state was not as notable that year, those were two very notable fires for those regions. So that is a fair comment there. But certainly in 2022 and 2023, we saw almost universally less active conditions. Yeah, Ava mentions that the Bureau of Land Management also has firefighters, which is of course true. There are wildland firefighters sort of scattered throughout a lot of different federal agencies. There's Park Service fire capacity as well. Although interestingly, a lot of the Park Service folks have a significantly greater mandate in a lot of parks, especially including places like Yosemite, to engage in prescribed burns as well as suppression of unwanted wildfires. That's somewhat less true of other agencies, but it varies even from park to park. So there's National Park Service firefighters, there are Bureau of Land Management firefighters, there's Forest Service firefighters, and as is mentioned, the patchwork of jurisdictions is complicated and sometimes unclear in certain situations. CAL FIRE is supposed to be responsible for state lands only, so not the federal lands within the state of California, but in practice, fires don't respect those administrative boundaries, and so usually on any fire of significant size, you have multiple agencies involved. One will usually take the lead, but there's usually, in almost any fire of significant size, multiple federal, state, and local involvement. Yeah, Mary is right that most of Australia's wildland firefighters are primarily volunteers. It is highly organized, though, and there is good equipment availability. So it is remarkable that most of them are volunteers, but at least there is a nationwide and certainly a territory-wide organization scheme where it's much as CAL FIRE is coordinated across all regions of California. The rural fire services in Australia have a similarly high degree of organization and a lot of specialized equipment. So they do actually have lots of wildland fire rigs, lots of task-specific wildland firefighting aircraft, things like that frankly a lot of states just do not have at any scale, and a lot of countries don't have at scale, including some countries that are quite wildfire vulnerable, as we've seen in recent years. All right, I think I'm going to call it there. Thanks for joining, as usual. And stay cool out there if you're inland, and I guess if you're at the coast, no need to stay cool. Stay warm if you're on the beach. That's a pattern that may continue. All right, everybody, thanks for joining. Please do share the channel and this conversation in particular. It really does help out. And with that, I will close and see everyone next week.